Hello, Victoria Baltasar here, reporting to you Wave and its Repeating Quantities, Conceptual Physics book by Paul Hewitt. In requirements for our instructional plan utilizing selected text. In our course, Teaching Adolescent Readers by Professor Victoria Moten. Standards taken are Next Generation Science Standards, MSPS 4.1, Waves and their applications and technologies for information transfer. Students who demonstrate understanding can use mathematical representations to describe simple model for the waves that includes how amplitude of a wave is related to energy in the wave. Common Core State Standards, CCSS Math Content 7 RPA 1, analyze proportional relationships and use them to solve real-world and mathematical problems. CCSS 7 RPA 2, recognize and represent proportional relationships between quantities. CCSS 7 RPA 2A, decide whether two quantities are in a proportional relationships. CCSS 7 RPA 2B, identify the constant of proportionality. Learning objectives, students will be able to describe the parts of a wave and draw them with 80% accuracy. Students will be able to draw, label, and describe properties of a wave with 80% accuracy, and students will be able to identify the evidence from the text, some of the energies transmitted by waves, and how waves were able to transfer energies with 80% accuracy. The big idea, waves transfer energy. First essential question, how do we describe the parts of the wave? What are the properties of the wave? This second question is not answerable by one sentence. There are a lot of properties of the wave. And last, how does wave transfer energy? Activator. For us face-to-face, students will be allowed to play a Snakey's vintage slinky toy and then ask about their observations on the movements of the toy with respect to the properties of the wave. Then the students will be asked to draw their findings on a construction paper. While online,
Slinky toys are fun toys.
It's Slinky, for fun it's a wonderful toy. What walks downstairs alone or in pairs and makes a slinkity sound. A spring, a marvelous thing. Everyone knows it's Slinky. It's Slinky.
So the questionnaires for the students while they're doing their engagement, how would the students describe the shape in the movement created by the Snakey's vintage slinky toy when they cause it to move? Do they see a pattern in the movement with the shape created by the Snakey vintage slinky toy? What did they observe with the shape created by the Snakey vintage slinky toy when they make movements faster or slower? So this is the first page for the chapter that has a close reading strategy, making connections. That vintage slinky toy, I got that idea from that page. So in the instruction phase, since I asked the students to draw how they see the movement of the snaky toy and their descriptions on it, then I have to collect that. And then I will formally introduce a simple wave. After which, I have to invite students to open their text on chapter 25, Waves, writing in their notes ideas they imaginarily highlighting in the text. So at least they would not write on the textbook. They can either use notes, post-it, index cards. So waves will be shown to them this water wave, then asked how do they decide how high they are drawing of the wave. Did they estimate that it should be in proportion on how low it would take? Such that the parts of the wave, like water wave, have high points on the wave called crests, while the low points are called trough. And on the properties of the wave, the amplitude is the distance from the midpoint to the crest or throw of the wave. So when students were drafting their wave, they will be asked if they feel the need to have a middle line between its highest points to its lowest points. So their drawing will be in proportion, right? While the wavelength is the distance from the top of one crest to the top of the next, or the distance from the bottom of one trough to the bottom of the next one. So the students will be asked in their experiences in swimming, either in pool or by the sea, what questions come to their mind when we have to talk about wavelength. The frequency is the number of waves go past a point per 1 second. So these are additional diagram for the students to get the concept not found in the book, pages of the book. So I also made a table of the concepts we are having, its symbol, its unit, and its the description. So in exploration, students will be asked to identify evidences from the text supporting descriptions of some of the energies transmitted by the waves and how waves were able to transfer energies. So in the explanation, I will show them videos to give a synopsis of the parts of the wave. This one is only talking about presenting the crest that is on the upper portion of the wave, and the trough is on the bottom, is the one at the bottom of the wave. There's no sound there. The repeating quantities of the wave.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats, only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases, and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example,
So this is just a reinforcement of what we have already, I have already explained earlier with the additional diagrams I have shown. I have also a differentiation for those who would want to do computations and to fill out the table based on the computations that they did. A close reading strategy, read across the curriculum, stretching text, reading increasingly complex text over time, look for evidence, and model it first. So the pages of the book has them. And for evaluation, I had those questionnaires. So thank you very much.